OSIRIS-REx, a NASA mission led by the University of Arizona to deliver an asteroid sample to Earth, is now orbiting its intended target, the asteroid Bennu. The unmanned spacecraft arrived last month. Scientists and engineers will spend the next year selecting the perfect place to collect a sample from the surface before the spacecraft's anticipated return in 2023. Until then, here's a look back at some of the highlights of the decade-long mission.
This is a sample return mission. The real holy grail is to return, and we promised NASA at least 60 grams, we'll probably return a lot more than that, to Earth in the year 2023 in September.
The type of object that we're going after is incredibly black. We think that dark surface is indicating a very carbon-rich material, and that is the prime objective of the mission, is to find very carbon-rich material that we think has organic molecules and prebiotic compounds that may have led to the origin of life on Earth.
My job is to pull the team together. I deliberately selected Don DiLoretto because of his skill set, his youth, his energy.
Obviously, the team suffered a major setback in September when we lost our leader, Mike Drake. And I was then asked by NASA to step up into the role of principal investigators.
We got one mission, it's going to go there, it's going to figure out how to operate around that asteroid, it's going to figure out the asteroid itself, it's going to decide where we want to go, it's going to go there, it's going to grab that sample, it's going to come back to Earth. All of those things, any one of which have been, a really complicated thing to do, we're going to do them all at once.
Lockheed Martin had developed something called the TAG-SAM, touch and go sample acquisition mechanism. It's something that we developed to actually do a sample without needing a scoop or needing to be attached to what we're sampling.
We do have a large budget. Our mission profile is, including launch vehicle, is just over $1 billion.
Schedule management is actually more important than cost management at this point. We're in a very healthy cost posture, but you simply can't buy more time for certain things. We've got a fixed launch date. We're going when we're going.
Everyone is go. 3, 2, 1. And liftoff of OSIRIS-REx.
The emotional roller coaster was incredible, thinking about everybody who's poured their heart and soul into this program, those who are with us, those who are not with us. Moment of liftoff was like a dream come true. We just nailed it, and it felt amazing. The OSIRIS-REx spacecraft is inbound back to the Earth after 1 year in outer space, and we are targeting an Earth gravity assist on September 22nd. The spacecraft will pass about 17,000 kilometers over the surface of the Earth, somewhere over Antarctica.
It's free energy, basically. We can achieve this inclination change without having to expend any of our own fuel.
We got color images about 1 day after the actual EGA event, and we were able to process all of those images into the color composites. We were able to do that in pretty short order, so I think that's just a great testament to how functional our team is.
So today is actually the first time we are going to take an image of our target asteroid, Bennu. We launched back in September 2016, and after about 2 years of travel, we're finally close enough to the asteroid where we can actually see it. It will just look like a star moving among the other stars. We're about 2 million kilometers or 1.2 million miles out, and much too far to even see it as a small round body. It'll just be a star.
All stations, stand by. Burn has started. Stand by for Bennu arrival. We have arrived.
So today we arrived at Bennu. We haven't taken orbit up yet, so we're going to spend a month going back and forth some distance away from the asteroid, roughly about 7 to 10 miles, examining it, taking images of it, checking out all our instruments, making sure everything is as expected, and then we hope to achieve orbit by the end of the month, beginning of the year.
Bennu almost looks exactly like we thought it would. Bennu has the shape that we predicted, and it's rotating in the way that we expected from the ground-based observation, but we are surprised by the size of the boulders on the surface and the density of boulders on the surface. So The surface is definitely much more rugged than we predicted from the ground-based astronomical observations.
First highlight was discovering evidence of water-bearing minerals on Bennu. It's one of the things that OSIRIS-REx really wanted to come and find. We're really trying to understand the history of our solar system, our place in the solar system, how life came to be, and that really means that we need to understand very early what was going on in the solar system, organic materials. Water is obviously a very fundamental component to life and its development.
The other surprise, I would say, about Bennu is that the surface looks really old. We expected this to be a young surface, having gone through an overturn as it flew by the planets and was modified by the tidal forces. But we're seeing some big impact craters on this asteroid. So we still have work to do to get closer to the asteroid, do higher resolution imaging to get a sense of the grain size. And are there particles that are small enough for TAGSAM to pick up? That's one of the big mysteries going forward. You think Bennu looks great now, wait till you see the data that are coming in March of 2019.
Arizona Public Media has followed the OSIRIS-REx mission for nearly 8 years. Production is underway on a second documentary chronicling its launch up until its sample retrieval. To view AZPM's initial documentary, Countdown to Launch, and find out more at azpm.org/OSIRIS-REx.